So the objective is to understand the law of conservation of mass, which is kind of what we've been building up to until this point. So there's a couple things we want to talk about here. First of all, a closed system is a system where nothing is added to or taken away from the original experimental setup. So if you think about all the labs that we did, the massive dissolved salt lab, we had a bottle with a lid that screwed on tight, right? So nothing could come in. The massive ice and water, we had a little plastic container with a lid on it, so nothing could come in or leave. The massive copper and sulfur, we had a rubber sheet with a rubber band on it, so the gas couldn't come out. And the mass of a gas, as soon as we poured the baking soda in, we put the lid on it tight so the gas couldn't escape. So those were all closed systems. Now, in the mass of the gas lab, there's of course, if you don't get the cap on quick enough, there's gas that's going to escape, and so that would be a reason why you would get a change in mass, because the system wasn't closed the entire time. All right? So law of conservation of mass says that matter cannot be created or destroyed. In other words, the number of atoms we start with, we end with. So when you put salt in water, whatever number of atoms you had, billions of atoms there, whatever that number is, you end with it. Okay? That's what the law of conservation of mass is. So as long as your system is closed, your mass should never change. So therefore, mass is a more useful measure of matter than volume, because mass doesn't change. If you think about all the labs we did, volume changed in every one. When salt dissolves in water, volume decreases a little bit. When ice melts, volume decreases. When copper and sulfur react to form copper sulfide, volume, I don't know exactly what the volume does. It's going to increase or decrease, one or the other. Okay, I'd have to look it up. And then when a gas is produced, volume is increasing. So the volume is changing, but because of the law of conservation of mass, mass is not changing. And then one more thing we're going to define, we talked about this last chapter, but we'll review it again. A law of nature is a generalization based on many experiments. So the law of conservation of mass is a law of nature. Okay? It's something that's reproducible. We can go back into a lab and show that mass doesn't change. And we get the same results over and over and over again if we do it right, if we have a closed system. So let's talk about what's on Canvas. And I'll put that back up there, Devin, if you don't have it all, okay? First of all, the announcements today. It says write the notes, which you just did, and read the conservation of mass section attached on Canvas. Answer 15 through 20 in your comp book. Answer the questions on the conservation of mass review worksheet, also attached on Canvas in your comp book. Then we're going to have a quiz over conservation of mass and histograms tomorrow. And I'm going to add something to this. I'm going to say, I'll put it right here. Answers will be posted later today. Okay, I've got the answers all written up, and we'll talk a little about some of them if you have any questions at the end of the hour, but then I'll post all the answers so you can look at them. And this would be a good way to study for the quiz, is this review stuff. So let's get on the module, and if you click on conservation of mass and laws of nature, this is what's from the book. So here's a reading section over conservation of mass, and there's question number 15 for that. And then a little bit about laws of nature, questions 16 and 17, and then some chapter review questions. Don't worry about the theme for a short essay. So read through that and answer those questions first. And then there's also a review worksheet down here. And there's 2 pages of questions here. Just answer these in your comp book too. All right? So that's what we're going to do today. We'll have a quiz over that tomorrow. And like I said, I'll post the answers probably down here at the bottom of this page, so you can go back there and look at them.